So that part is very important, not for your for only this C syllabus, but that is also important in when you are facing gate questions, or you are facing interview, right there. So the thing is that the program that is given, say this is a void, the program is given like that, say integer n, say integer sum, and the thing is that this is given integer k is equals to 0 and say j equals to 0, and if n equals to 0, this is written, and k is equals to n modulo 10, and j is equals to n is divided by 10, sum is equals to sum plus k. I am calling the same function j sum, and I am writing printf. I am writing this printf. This is a percent d and k. So the thing is that, and I am writing say integer main, say this is integer a is equals to 2048, say sum is equals to 0. I am calling this particular function a sum, and I am writing this printf. This is percent d sum. So this is the corresponding you know this is the corresponding program that is given, and you have to say what should be the output. The first thing you should remember, that whether we should follow the recursion tree process, or whether we should follow whether we should follow the stack method. So when the function contains itself the function, if this is just intuitive feelings, that is not any hard and fast rule like that. This is not a rule, but that is the intuitions to solve the problem, that you can think that when the function when the function contains when the function contains many lines, when the function itself contains many lines, that will be better to use the stack method. Yes, that will be better to use the stack method. And when most of the function, when most of the functions, most of the function are recursive, that means we are calling recursive functions. So it is better to use it is better to use free method. It is better to use free method. So the thing is that when most of the functions are recursive, so it is better to use free method. And when the function contains many lines, right, so we have to use the stack method. That is the rule that we can follow. So now the thing is that, so when you are using stack method, I am just giving the line. That means say this is a line number 1, line number 2, line number 3, line number 4, line number 5, line number 6, right. So the thing is that, what is the process of using stack method? That means when you are using the stack method, that means first we have to start from main, right. I'm writing there. If you can understand the thing, let me know. uh, Let me know. Okay, just a minute, একটা কল আসছে, আমি ধরে নিয়ে আসছি, just a minute. So the thing is that in case of stack method, that means the functions started calling with main. That means this is a main, so the main function is called, that will be pushed into the stack, and with the that is the activations record. That means the variables, that means within the main the value is a is 2048, and the value of sum is 0. So that will be pushed, that will be a is equals to 2048, and this value of sum is equals to 0. That will be pushed within the main. And after you are calling the recursions, and before calling the after calling the recursions, you have to back to this particular statement. That means I am not giving any line. Say this line is 7. So this particular line, so I am writing this is the instruction pointer that will hold you know the that will pointer that will hold the next line that will print when you are back uh, um, pop the content from the stack, and then you have to print the line number 7. So that why what I'm saying, this 7 is nothing but instruction pointer that will be discussed in the previous class. So now when you are calling this particular functions, right, I am calling this foo, that means corresponding the foo functions will be called. And that the functions, when you are calling these foo functions, you are passing the value a and you are passing the value sum. The value of a is 2048 and the value of sum is 0. So when you are calling the functions, so this n, that particular n will contain 2048 and this sum will contain 0 because you are calling the function a and sum. That means a will be 2048 and the sum is equals to 0. So the thing is that the value of n, that is 2048, and this particular sum is equals to 0, right? This sum is equals to 0. And of course when the sum is equals to 0, the local variable that will be pushed into the stack. So the value of k is equals to 0 and value of j is equals to 0. So now you are checking that whether n equals to 0, that condition will not satisfy, but because the n is 2048, so it will execute the next line is k equals to n modulo 10. So k equals to n modulo 10. What is the value of n? Value of n is 2048 modulo 10. That means it will give you 8. This is a remainder. And value of j is n divided by 10. That means this is the value of k. And the value of j is equals to n. N is 2048 divided by 10. That means this is nothing but 20 8. And the value of sum is equals to sum initially, that is 0, and now you are adding the value of k, that means that becomes 8. And then you are calling the foo functions with the value of j. Value of j is 208 and the sum is 8, right? You are calling this. So that means that will be changing. That means the value of sum is become 8. Value of k is changing. The value of k is 8. Value of j is also changing. That value of j is, in that particular case, that is 204. This is not 8, 204. This is 204. So this is 204. And you are calling this is the local variable you are storing in the stack. This is called activation record of the stack. And when you are calling the function, and after that you have to print this, that means you have to back to this line. So the instruction pointer will pointing this line number 6. And again you are calling foo functions, and when you are calling foo functions, you are calling with j value is 204 and value of sum is equals to 8. So what will happen? That means again you are calling the same function but with different value, and the value is nothing but the value of n is 204 and the sum is 8, right? So when you are calling this function, the value of n is nothing but 204 and sum is equals to, that is 8, right? And initially that again the value of k is equals to 0 and j is equals to 0 and n is equals to 0, but that will not correct. So you are calculating the value of k equals to n modulo 10. Here you just see the k is equals to n is 204 modulo 10. That means that will be 4, and j is equals to n, that is 204 divided by 10, that is 20, right? So the value of k will be updated, that will be 4. Value of j is 20, and the sum is also sum plus k. So initially the sum is passed with 8 and sum plus k. What is the value of k is 4, that means 12. So the thing is sum is become 12, and you are calling again the same function. So the return you are returning with the line number 6, and you are calling with the value you are calling with j and sum. What is the value of j? J is 20 and value of sum is 12. You are calling this 20 and 12. So again the value of this n is equals to 20, and this sum is equals to 12, and value of k equals to 0, j equals to 0. So k is nothing but n is this n modulo 10, that means 0. So k is remains 0, and value of j is 2, and the sum will be updated, but that will add it with 0, so it remains 12, right? It remains 12, and after that you have to back to the line 6, and you are calling the foo function with the value of n. The value of n is nothing but 2, because your n modulo 10 is given. So the value of, you are calling the j and sum, so you are calling with the value of n is 2 and the sum is 12. So n is 12, 2, and the sum is equals to 12. So initially k is 0 and j is 0. So that k is equals to n modulo 10. So n is modulo 10, that will give you 2, right? So the value of k is equals to 2, and n modulo n divided by 10, that means 2 is divided by 10, that means this is 0. So that will be 0, and the sum is updated and it becomes 14. And now you are calling, you are have to back to the line number 6, and you are calling the foo with the value of n is equals to 0, because you are calling the function with j and sum. In that case j value is 0 and the sum is 12, sum is 14. But this condition will satisfied now, this condition will satisfied now, because the value of n equals to 0, then it will return. Then what will happen? What will the meaning of that? That means that will not execute it and it will return, right? It will return. And where it will return? It will return, it will return to the line number 6, and line number 6 is nothing but you are printing the value of k. So when you are printing the value of k, you are just looking that the value of k within the stack activation is 2, right? So it will print 2 first, it will print 2, and you will pop it, and after popping you are again back to this. That means when you are pushing into the stack, the printing will not occur, that you should remember. When you are giving the return statement, when you are back and when you are pop the content, then the printing will be executed, right? So first it will print 2, and after that it will back to the next function, it will execute the line number 6. In line number 6 there is printf and printing the value of k. Within the stack the value of k is 0, right? So it will print 0. Again it will be popped, and it will go to the line number 6. In line number 6 you are printing the value of k. Value of k in that particular line is 4, so it will print 4. Again it will back to this line number 6. Line number 6 will printing the value of k. The value of k is nothing but 8, so it will print the value of 8. And again it will back to the main, right? That, and line number 7, and in line number 7 you are printing the value of sum, right? That, so value of sum is 0, right? So it will print 0. So the output is nothing but it will print like that, 2 0 4 8 0. So this is the output. So that is the thing that you should remember, right? And that is the important thing of recursions. That means when you are dealing with recursions, when you are dealing with stack, you are just push the content of the stack. That means that is called the activation record of the stack within and then when you are popping the content, then you are printing the value, right? When you are pushing the value, you are not printing. And after execution the base conditions, that means return condition, when the recursion fails, and after that the popping will start, right? And it will execute it like that. So that is the important thing that you need to remember, right? So it will print like that, 20480, right? So this is the one example that I gave to you in the previous class, and the next one is like that. Say I am giving like that integer f, this is integer start a, integer n, বলো।
স্যার এটাকে স্যার ট্রি দিয়ে করা যেত না, যেটা এখন মানে স্ট্যাক দিয়ে করলেন?
হ্যাঁ, ট্রি দিয়ে করা যেতে পারে, বাট দ্যাট উইল ক্রিয়েট তোমাকে অনেক কিছু ভাবতে হবে, অনেক কিছু করতে হবে, রাইট? তার কারণ ব্যাপারটা ট্রিতে গেলে তো তোমার ট্রিতে কি করি, উই আর কলিং দ্য রিকারশন ফাংশন অ্যান্ড জাস্ট উই আর এক্সিকিউটিং ওয়ান অর টু প্রিন্টেড স্টেটমেন্ট, তাই তো? তুমি ট্রি দিয়ে করতে পারবে না কেন? করতে পারবে, বাট তোমায় খাটতে হবে, অনেক কিছু মনে রাখতে হবে। তাই জন্যই বলে দিলাম, যখন ফাংশনের মধ্যে অনেকগুলো ভ্যারিয়েবলস থাকবে, তখন মানে ফাংশন যেটা রিকার্সিভ কল হচ্ছে সেটাই ইটসেলফ অনেক বড়, তো দেন ইট উইল বি বেটার টু ইউজ দ্য স্ট্যাক মেথড, তাতে তোমার বুঝতে বা এক্সিকিউট করতে সুবিধা হয়। আর যখন তুমি শুধু ফাংশনটাকে বারবার কল করছো with some statement, তখন কিন্তু it will be better that if we are using this tree method. যেমন in that particular case
ঠিক
this is
আছে
integer main, I am writing like that, say integer a, this is an array, and this is say 12 7, this is 13, this is 4, this is 11, this is 6, and I am printing this particular percent d if a6, write that, and I am just writing this is return 0. So in that particular case you are just saying that we are calling the recursive function, right? We are calling the recursive function several times. So in that particular case, when you are calling the recursive function several times, so it will be better to use the tree method, right? So before going to the tree method, you are saying that that is an array, right? And I think now you are know all about the thing that means pointer using array. So if this is 12, this is 7, this is 30, this is 4, this is 11, this is 6, and the thing is that this is an array, and if the starting element is 100, the next is 104. If we take the integer, we'll take 4 bytes. 108, this is 112, this is 116, right there, and this is 120. So this is the corresponding address. So now if we use tree method, that will be better, but you are calling the functions, right? You are calling the function a comma 6, right? What is a is nothing but the base address of an array, right? So you are calling, পয়েন্টার দেখে ঘাবড়ে যাবেন, the thing is একটু মাথা ঠান্ডা করে ভাবলে you can do it, that if is you are calling this function with the address, because you are calling a comma 6, when you are calling the array, actually we are passing the base address of an array, right? We are passing the base address of an array. That will not give you the content of the array, right? That will only give you the base address of the array. In that particular case, I am taking the base address is 100, so it will call the functions 100 comma 6, right? And when you are calling this function 100 comma 6, that means it will go there, that means this is 100 and the value of n is 6, right? So the value of n is less than 0, this condition is not satisfied, so it will go to the else, right? So in that particular else, what is the meaning of star a? You know that. What is the meaning of star a? Star a is nothing but the value at it, right? This star a is nothing but, what is the meaning of star a? It is nothing but value at
স্যার বিটা
100, right?
স্যার বিটা কি বিটা 6 হলো কি করে
Beta, that is a 6, আমি তো 6 পাস করিয়েছি, আমি তো এখানে 6, এটা b নয়, I am passing the value of 6. This is the 6, okay? So the thing is that so this is the value of 100, value of 100 is nothing but 12, right? So you are checking in that particular condition, what you are checking, the content of the array, this modulo 2 is equals to 0 or not. That means if it is 0, that means the content of this first location of the array, that is even. So if it is a even, so what we are deduce, if the content of the array is even, then it will call this, and if it is odd, then it will call this, right? That is the simple thing. If you can decode it, then you can do it easily, right? So the thing is that the first we are getting the content, that is the 12, and 12 is nothing but even, so it will call this particular function. What is the particular function? That is the star of a, that means value at 100, that means value at 100 is 12, and plus you are calling the function with a plus 1. This is a pointer increment, that means if this is 100 in the base address, I am adding 1 multiplied by data byte, so it will goes to the next location, which is 104, and this is n minus 1, that means n is 6, so now it is 5. So I am calling the function with 104 and 5, right? I am calling the function with 104 and 5. That means the pointer is now, you are calling the function, that means this will now 104 and this is now 5, right? And this condition will not satisfy, and that content is odd, right? If it is a odd, that means if the checking fails, then it will return this particular functions, right? So the thing is that nothing but that, you are calling the star of a, that means value at 104 and value of 104 is 7, so it will 7 minus, I am calling a plus 1, a is 104, that means it will again incrementing and it will pointing to the next location, and next location is 108, and the value of n will be decremented it become 4, right? And again we are calling the same function with the value, this is 108 and that become 4, so again 108 content, that is 13, 13 is odd, and if this is odd, you are calling the same function again, that means the value of 108, that is 13, you are calling the function with the increment, that becomes 112, and n minus 1 is nothing but 3, right? So the thing is that you are calling again the function, that means pointer is pointing like that, you are that is 112, you are calling with 3, so 112 content, that is 4, 4 is even, 4 is even, so you are calling this particular function, star of a means value of 112, that is 4, and you are calling this function a plus 1, a plus 1 means 116, and n minus 1, that is 92. So again you are calling it with 116, and this is 2. So 116, that content is again odd. If this is odd, you are calling this particular function, so that means this is element minus f, this is 120 and 1, you are calling this 120 and 1, so it will again pass, and this is last, this is 120, this is 1, and it will goes, and within the content, that is the event, this is a 6, so we are calling this this function, we are calling this function, so that means we are calling this particular function, the content is that will be 6 plus f, this is 124 and 0, and so you are passing it, you are passing 124 and that is 0, and when this is the 0, this condition satisfies, so it will return 0, right? So if it is return 0, what will happen? You just see, it will return 0, right? So the thing is that this particular function will return 0. So 6 plus 0, this is 6. This 6 will be substituted there, that means 11 minus 6, that will be computed, that will 5, that be there, that means 4, you know 4 plus 5, that will be 9, then 9 will be there, that is 13 minus 9, 13 minus 9 is equals to 4, then this 4 will be passed there, that is nothing but 3, that 3 will be passed there, that means 12 plus 3, that will 15. So this particular function will return 15, right? So the output, you are printing this, so the output is nothing but 15, right? So that is the process by which you can think the recursion will work. Okay, so that is the thing that you should know, that how the recursions will work. So that is the way by which the recursion is working like that. So the thing is that if you that is the problem, if you know the problem, you can solve the easiest problem. That means in your in your matout or exam or WT exam, what we'll find, that they have to give you that you have to find a factorial of a recursions, right? To find the factorial of a number, to find the factorial of a number, right? So if you want to find the factorial of a number, the factorial of a number by using recursion, of course, by using recursion, by using recursion. So if you want to do that by using recursion, that means you are calling the same function several times. So the thing is that I am writing the code like that, then we are explaining it. That means I can write like that, say as include stdio.h. I am writing this type def. I already told you that long unsigned integer, I am saying that can be denoted by capital L. So I am just using L. This L means actually I understand long unsigned integer, so I'm not writing this long unsigned integer several times, so I'm writing like that. This is a fact, integer n, and if the value of n is less than 2, I am returning 1, else otherwise I am returning, this is a n factorial, fact n minus 1, because I am writing the function that is a fact. That means you are calling the factorial function once again, right? N fact n minus 1, write that. And the thing is that I am writing this integer main, and the thing is that integer I, and the thing is that printf enter a number, and I am say using scanf, that is percent d and percent I, and I am writing printf say factorial this percent d, this is percent ld I, and I am calling this factorial I, right? And the thing is that return 0, I am writing return 0. So this is a simple factorial program, and how it works. If you see that I want to calculate the factorial, if I want to calculate the factorial 5, say, so the user will give input, right? That the user will give input say 5. That means I have to calculate the factorial 5 value, and you are calling this factorial function 5. You are calling the factorial function with 5. So the thing is that it will be it can be working like that. That means first you are putting the main, and the thing is that you are printing this. That means if we write 1, this is 2, this is 3, this is 4, and this is 5, so you are printing. So that means you are calling, you have to print this particular line. So this is the line number 4, and say I'm just writing casually this 6, this is 7, this is 8, this is 9. So the thing is that you are calling the factorial. That means you are calling this particular factorial 5. So when you are calling this particular factorial 5, it will call these factorial functions. 5 is less than 2, that will be checked. That means this condition is not satisfied, so it will push in the stack. This is 5 multiplied by fact 4. And when you are calling this fact 4, that means again this fact 4 will be called. Again this fact 4 will be called. That means this is a line number say 10. That means this is a completion, line number 10 will be back, and you are calling the fact 4. Fact 4 means again you are calling the same function, 4 multiplied by fact 3 will be pushed, and again you are calling fact 3. That means 3 multiplied by fact 2 is been pushed, right? When you are calling fact 2 is less than 2, that condition is not satisfied, so you are calling fact 2, and 2 multiplied by fact 1, and you are back to 10. And when you are calling fact 1, this fact 1, this condition is satisfied, so it will return 1. So that particular thing will be popped and it will return 1, right? So if it is return 1, that should be multiplied by 1, that is 2, because you are line number 10, your box that will be popped, and that particular value will be substituted there. That means 3 multiplied by 2, that means 6. You are calling this, you are popped this, then this particular value will be replaced there. That means 4 multiplied by 6, that is 24, and this will be popped out. And then again factorial 4, you have to put this value. That means 5 multiplied by 24, that will give you 120, and then you are executing line number 4. So line number 4, you are just printing the value of factorial is 120. So you can write the factorial program by that. That means all recursive function works in two phases, right? All recursive functions, that is, works in two phases. One is called that is called winding phase, that means we are pushing the content into the stack. And that another thing that is called unwinding phase. And in case of unwinding phase, that means you are popping the content of the array, right? So winding phase, that will begins with the recursive function is called for the first time, and each recursive call that will continue in the winding phase. And in that particular phase, the function keeps on calling itself and no return statement are executed in this phase. And this phase terminates when the terminating conditions become true, right, in a call. When the termination conditions is become true within a call, right? So in that particular case, what will happen in that particular case? So after this unwinding phase begins, that means all the recursive function calls start returning in reverse order till the first instance of the functions return. So in unwinding phase, the control returns through each instance of the function. So the thing is that in some algorithm we need to perform some work while returning from recursive call, and that case we put that particular code in the unwinding phase just after the recursive call, right? So your function will that will be executed like that. So the thing is that it will be better that if you can write the recursive functions on, that means I'm given some home task because that is important, that you if you can write your recursive functions, that means if a simple program says this is the home task, আমি কিন্তু দেখব পরের দিন, that means if we write 1 plus 2 plus 3 plus 4 like the sum of the natural numbers, right? Sum of the natural number by using recursions. Of course you have to do it by using recursion. By using recursion you can do it. And the thing is that uh, a sum of digits of an integer, right? Second home task you can say that sum of digits, you already did it but not using recursion. So sum of digits of an integer, sum of digits of an integer, that this is a second. And the third is you know uh, this conversions, that means if we want to convert decimal to binary, decimal to binary, of course using recursions, that all are only using a recursion, that means using recursions. Using recursions you can, whether you can do it or not, right? And this is also another home task, that is prime factorization. Prime factorization. Prime factorization, what is the meaning of that? The prime factorization of a number, that will means factoring a number into product of prime number, right? Like that, if we take this is 84 and 45. So 84, that means 2 multiplied by 2, that means 4. 4 multiplied by 3, that should be 12. 12 multiplied by 7, that is 84. And the thing is, this can be done by 3 multiplied by 3 multiplied by 5. Now to find the prime factor of a number, we check its divisibility by prime numbers like 2, 3, 5, 7 till we get a divisor d, and now d becomes a prime factor, and the problem reduces to finding the prime factors of n by d. That means if we want to find the prime factor of a number n, I have to check its divisibility. I have to check its divisibility by prime numbers. Divisibility by prime numbers. Right? Till we get a divisor d. Till we get a divisor d, right? So d becomes a prime factor. So this is the thing. And another thing that you have to do, that is the finding gcd. Finding gcd, how to find the gcd by using normal program. You have to find the gcd by using recursions. And also you have to find the Fibonacci series. That is also important thing. That means Fibonacci series, Fibonacci series by recursion. By recursion, how can we write the Fibonacci series? There may be different procedure, but you can follow any one of this. That will be the thing. And there is also another important problem, you know another important problem that we can see, that is called Tower of Hanoi. You just go through the Tower of Hanoi problem. If it is not understandable, then I will discuss it. But that is also another famous problem that will be implemented by using recursion. That will be implemented by using recursions. So just go through the Tower of Hanoi problem. If you feel that you are not comfortable with the Tower of Hanoi problem, you will not understand the thing. So the thing is that you just tell me in the next class we will start discussing with the Tower of Hanoi problem, because this Tower of Hanoi problem will in data structure, when you are implementing, when you are dealing with the stack, you will see that there is also you have to implement this Tower of Hanoi problem, right? So the thing is that that is the important problem. If you will not understand the Tower of Hanoi problem, then I will discuss it. But before that, at least you try to understand, because that is the one of the famous problem that you should know. So the thing is that, so we know, okay, so recursions, but the thing is that, yes, কিছু বলবে তো বলো।
বলছি স্যার ওই একটা প্রবলেম দেখছিলাম, মানে সেলিব্রিটি প্রবলেম বলেছিল। তো
হ্যাঁ,
এই
দ্যাট উইল বি,
প্রবলেমটা
হ্যাঁ,
কি ধরনের,
ওটা
কি
এখন,
জিনিসটা?
ওটা স্ট্যাকের প্রবলেম, বাট আমি পরে ডিসকাস করবো, রাইট? ওটা স্ট্যাকের প্রবলেম, দ্যাট ইজ আ সিম্পল প্রবলেম, দ্যাট ইজ নট দ্য থিং. So that is the problem. You can solve it by using stack. So we will discuss it later. So the thing is that in recursion you should remember one thing. That means recursion is a huge overhead, right? When you are using recursions, that recursion is a huge overhead. This is a huge overhead, both you know in terms of, memory and of course execution time, right? Because you have to push it into stack, you have to pop it out within the stack. Of course that will take a huge time. In space of you know in space of in case of iterative program, that will more faster than the recursions. That you should remember the thing. That means the thing is that all repetitive problem can be implemented either recursively or iteratively. So in loops, the same block of code is executed repeatedly, and repetition occurs when the block of code is finished or a continuous statement is encountered. In recursion, the same block of code is repeatedly executed and repetition occurs when the function calls itself, right? So the thing is that in loops, the variable inside the loops are modified using some update statement. In recursions, the new values are passed as parameter to the next recursive call. So of course, recursive involves pushing and popping activation record of all the currently active recursive call onto the stack. So of course the recursive function of a problem is usually slower because of the time spent in pushing and popping this activation record. So it is also expensive in terms of memory, as it uses space in runtime stack to store this activation record. And it is also expensive in terms of memory, as it uses space in runtime stack to store this activation record. So if the recursion is too deep, right, it's too deep, that means you are calling the recursion several times, then the stack may overflow and the program will crash. So on the other hand, the iterative versions do not have to pay for this function call overhead, so are faster and requires less space. Okay, and the recursive functions involve more execution overhead than the iterative counterpart, but their main advantage that they simplify, right? The main advantage is nothing but you know the main advantage of recursive functions, the main thing of recursions, that you know Recursion should be used when the underlying problem is recursive in nature. That means when the data structure on which we are operating is recursively defined. That will, like trees. And iterative should be used when the problem is not inherently recursive or the stack space is limited. Okay, because there are some problems which are very complex, so iterative algorithms are harder to implement it, and in that case it is easier to solve them recursively. So in that cases, recursion offers a better way of writing the code which is both logical and easier to understand and maintain, but sometimes it may be worth sacrificing efficiency for code, readability. So that is the, that is the recursions. But of course you just remember that it seems in recursions we are involving pushing and popping the activations record of all the currently active recursive calls on the stack. So the recursive versions of a problem is usually slower than the, that compared to the iterative program. That will be understandable. So the next thing that will be in recursions, that is called, tail recursions. That is called the concept of, tail recursion. This is called, tail recursions. What is the meaning of tail recursions? That means a recursive call, a recursive call is, tail recursive. A recursive call is tail recursive if, it is the, last statement. It is the, last statement to be executed. It is the last statement to be executed, inside the function. This is the last statement to be executed inside the function. That is the tail recursion. That means we are writing the same recursive program. আমার একটুখানি মিউট করো তো। The thing is that we are calling the same recursion program but in a different way. That is called tail recursion. How? So let's see, I'm writing the same factorial program. I'm just writing the, functions. Say I am writing the functions like that, long fact, long f, and long n, right? So I'm just writing that if this value of n is less than 2, I am just returning f, right? And then I am calling, f star n, n minus 1. I am just writing this recursive function. Main is there, and I am, you are calling the, say, factorial program with passing 1 4. That means I want to find the factorial 4, right? So I am calling the function from main, 1 comma 4. Then what will happen? The value of f is, 1, and value of long is n is 4, right? So, factorial. So I am calling this like that, fact f is equals to 1 and n is equals to 4. And this particular condition is not satisfied. That means if, n, that means 4 is less than 2, this condition is not satisfied. Then they will call again the factorial, which is f star n, n minus 1. F star n means 1 multiplied by 4, 3. That means actually fact 4 comma 3. We are calling the same function. That means now this is 4 comma, 3. So this, 3 is less than 2, this condition is not satisfied. So again I am calling this fact. This is 4, 4 multiplied by 3, n minus 1 is 2. That means this is nothing but, fact, this is 12 and 2, right? So you are calling 12 and 2. So this is nothing but 12, this is 2. So this condition is not again satisfied. So I am calling the function, fact 12 multiplied by 2 and 1. That means equivalently this is nothing but fact, that is 24 1. So when you are calling this function, you are just saying that you are pushing into the stack, right? You are pushing the value like that. I am pushing the value, right? First, main will be pushed in the stack, and then, fact, this is 1 4 you are calling. Then, this fact you are calling, say, 4 3, that will be pushed into the stack. Then you are calling fact 12 2. Then you are calling the fact, 12 24 1, right? When you are calling the 24 1, right, that means this 1 is less than 2, this condition is satisfied. So you are returning the value of f, right? So when you are returning the value of f, this is f. So you are just return f. That means I am returning the value of f. F is 24, right? So the thing is that this is the, so what is the definition of tail recursion? A recursive call is tail recursive if it is the last statement to be executed inside the function. You are just, we are pushing this tab, there is no need to pop, right? That I am just popping this first statement and you are getting the result, and result is nothing but 24, and that is nothing but the tail recursion, right? So in tail recursive function, the last word that a function does is a recursive call, right? The last thing, the last work that a function does is a recursive call. Yes, any question? Any questions?
স্যার আপনার অ্যাকচুয়ালি থেমে গেছিল মাঝখানে।
Oh, so then যদি if there is a problem একটু ভিডিওটা দেখে নিও, রাইট? বাট আজকে নেটওয়ার্কটা ইস্যু
আচ্ছা।
হচ্ছে, তো ভিডিওটাই পেয়ে যাবে, যদি কিছু অসুবিধা
হ্যাঁ,
হয়
হ্যাঁ।
দ্যাট উইল বি, আমি আজকে আপলোড করে দেবো, ইউ জাস্ট সি দ্য ভিডিও একটুখানি, তাহলে ব্যাপারটা ক্লিয়ার হয়ে যাবে, কিন্তু এই জিনিসটা দেখো,
ওকে।
রাইট? So the
আচ্ছা।
thing is that tail recursive function, the last work that the function does is a recursive call. So no operation is left pending after the recursive call returns, right? No operation is pending after the recursive call returns. So some modern compiler can detect tail recursion and perform tail recursion optimization. So say do not push a new activation record, right? When a recursive call occurs, rather they override the previous activation record by current activation record. Why? That means they are not pushing the thing. They are in modern compiler. They will just override the thing, because that you need not to pop the thing, because the last thing that will be executed, that will be the result. So if we just overwrite the thing while retaining the original return address, so we have only one activation record in the stack at a time, and this is for the currently executing recursive call. And of course that improves the performance by reducing time and memory requirement. So it does not matter how deep the recursion is, the space required will always be constant if we use tail recursion. So in a modern compiler, what will happen? That means what will happen? You are calling the main, right? And then you are calling the factorial 1 4. So you are overwriting this with the fact 4 3. You are overwriting with the fact 12 2, and then you are overwriting it with the fact 24 1, and you are returning the value 24. So there is no need of stack preparations like that. You are not, whether the stack will be recursive call is deeper and deeper, it we don't have to worry about that. So it will be better just you take at home, just because the thing is that whether you can implement or not, that will be the thing. That try to implement GCD, right? That using tail recursion, that is the tail recursion. Just try to implement the GCD by using tail recursion. I think you can do it. I can do it. You can do it, because it is important, since the thing is that since tail recursive is very important in that respect. So if you can implement the basic program by using recursion and tail recursion, that would be beneficial for you, right? So the thing is that this is my request, that please do do the program, and that will be better for you, right?